For one last problem, set up, but we won't evaluate, a triple integral that gives the moment of inertia about the z-axis and just the z-axis of a solid Q with density function. The density at the point x, y, z is proportional to the square of the distance from the yz plane, so k times x squared. So Q is inside of the cylinder, x squared plus y squared is less than or equal to 1. And above the xy plane and below the paraboloid, z equals 4 minus x squared minus y squared. So I'm not going to evaluate it, but if I were, I'd probably want to switch to polar coordinates, but that might not necessarily be best, but it looks kind of best right now. But still, we're just setting this up, not evaluating it. Our moment about the z-axis, we need x squared plus y squared here. This is our density function. dz dy dx is an obvious choice. Z going from 0 to 4 minus x squared minus y squared. Since we're inside the cylinder, then we just look at the region in the xy plane, x squared plus y squared less than or equal to 1. That would be a circle. And so our lower limit would be, and by the way, the circle as a function of x would be y goes from square root of 1 minus x squared, negative square root of 1 minus x squared to positive square root of 1 minus x squared. So that's that part, and x going from negative 1 to 1. And you say, well, couldn't we just use symmetry? And the answer is no, because this is not a constant. If this was a constant, then yes, symmetry is usable, but since it's more dense in some regions than others, it's denser the further we get from the YZ plane, then we can't necessarily use symmetry. And I have a small picture of the region, but you have to consider I don't have the intersection with a cylinder on here, but if you can imagine just above the circle of radius 1, so about where the borderline of the yellow and the green is, that would be what our region looks like. So hopefully that's understandable.